Okay, so we start looking at partial fractions. This is a very, very short topic. It only has, in itself, it only has two types. We only have two types. And each type has two varieties. Each type has two varieties. Of partial fraction. So where we have the first type, linear denominators. Second type, quadratic or polynomial denominators. So now categorize them in examples. Resolve into partial fractions. So questions now I'm getting from the past papers. Since we are doing a revision, so when you get a topic, when you go to the past papers and get questions from there, so that when we revise past papers, there will be nothing to solve. 4x plus 5 over x plus 2 multiplied by x minus 1. So this is an example of type 1. The naming of type 1, type 2 is just to differentiate and to keep it for ourselves in memory well, that when I have this type of equation, this is where I do this and that. Otherwise, the names are type 1, they're not important. It's just to help us remember what we would do when we meet such a question. So if I have 4x plus 5, and the denominators have powers of x equal to 1, then you just need variables and then pick the denominator factors each at a time. So a over x plus 2, b over x minus 1. Your first step is to multiply this whole thing by x plus 2, x minus 1. So that we have this guy here multiplied by that guy. The denominator will cancel with that thing there. So we'll remain with 4x plus 5 is equal to this one multiplied by this one. X plus 2 will take away x plus 2. So we'll remain with a multiplied by x minus 1. So we'll remain with a multiplied by x minus 1 plus multiply this one times this one. We'll have x minus 1 take away x minus 1. And then we'll remain with x plus 2. So we'll have b x plus 2. Moving from here, we have two options. You can either choose, you let x to be equal to 1, because you know that if you do that, this piece is going to disappear. So we're going to have 4, 1 plus 5 is equal to a, 1 minus 1 plus b, 1 plus 2. So we'll have 4 plus 5, 9. is equal to 0 here. 1 plus 2, 3. So we get 3b. Implying that if you divide by 3, we'll get b to be 3. So we have found b. We need to find a. You go back and say, let now x be equal to -2. Because you know that if x is -2, then this part is going to disappear. And then you're going to have a. So we substitute 4 by -2 plus 5 is equal to a, -2 minus 1 plus b, -2 plus 2. If you know that this guy is going to be 0, it's not even important to substitute here. All right. So if you know that when you take x to be -2 in this equation, the b part is going to be 0, you may choose not to write it even here. So now we'll have 4 by -2, we get -8 plus 5 is equal to -2 minus 1, we get -3a. Now -8 plus 5, that is -3, which is equal to -3a. Divide by -3, divide by -3, we obtain that a is equal to 1. So we go back to our partials and say, therefore, 4x plus 5 over x plus 2 multiplied by x minus 1 is equal to a is 1 over x plus 2 plus b is 3 over x minus 1. So these are the partial fractions of this combined fraction. If you're not so sure, or if you're doubting your solution, you can actually take this 1 over x plus 2 plus 3 over x minus 1 and put it together, add and see what you get. We must get the question. No, the sign between the fractions can only change from plus if you get b to be negative. It does not depend on the sign in the numerator. It will initially be plus until it is changed by the values that you get as a and b. So now if you want to confirm whether what you have gotten is correct, you get the common denominator between 1 over x plus 2 and 3 over x minus 1. So we'll have x plus 2, x minus 1. And then x plus 2, x minus 1 divided by x plus 2, we get x minus 1. Then multiplied by 1, the numerator of x plus 2. So we'll have x minus 1 plus 3 multiplied by, you divide x plus 2, x minus 2 divided by x minus 1, you get x plus 2. This is giving us x minus 1 plus 3x plus 6 over x plus 2, x minus 1. We simplify x plus 3x, we get 4x. -1 plus 6, we get 5 over x plus 2, x minus 1. So seeing that this is what we have as our question, then you know that your partials are correct. Now you only do this if you have time. Meaning that you must be sure that you have checked your steps and there's no mistake, so that you don't waste time checking. So this is the simplest type. Now, if you find that your question looks almost like this type, but then one of the geometer has been squared, we call it a repeated linear partial. An example, B, if I have 3x plus 7 over x squared, x minus 1, x plus 1. We have x squared here, meaning that we have a repetition there. So this is going to be a over x, because x can go in x squared, plus b over x squared, plus c over x minus 1, plus d over x plus 1. So we are splitting, getting all the factors of the common denominator that we have down here. Okay. Then the first step is still the same. You multiply this whole thing by this denominator that we have here, x squared, x minus 1, x plus 1. So this guy will take away that guy when you multiply in this piece. So we'll have 3x plus 7.
Yes, I have a question. Where is the x coming from? The which is on a over x. Where is the x coming from?
So we're looking
from
for
a denominator.
So the idea here is we're looking for all the factors of this lowest common multiple. So I know that if I have x squared, I can divide x squared by x. Is it?
Okay, yeah, understood, sir. Thank you.
So we have 3x plus 7 after multiplying this guy by that one there. And then this is equal to a, this x, when you multiply, it will take out one of the x from x squared, but it will do nothing to x minus 1, x plus 1. So here there will be x multiplied by x minus 1, x plus 1, plus b, the x squared here will take away the whole x squared and will remain with x minus 1, x plus 1, plus c, the x minus 1 down here will take away the x minus 1 here. So we'll remain with x squared, x plus 1, plus d, the x plus 1 will take away the x plus 1. So we remain with x squared, x minus 1. Now here, if we try to let x be 0, we can get the value of b. So if we let x to be equal to 0, it means that everywhere where x is there, we'll take 0, we'll take 0, we'll take 0. So these three pieces will disappear. And on the left, there will be 0 here. So we'll have 7 is equal to, there will be 0 here, there will be 0 here. So we'll get b negative 1 multiplied by 1, giving us negative b is equal to 7, which implies that B is equal to -7. So your choice of X is equal to 0, is equal to 1, is equal to what? You are looking at the equations that you have in here, the expressions that you have here. What can make any of them to be 0? In other words, you are getting these guys here and equal to 0. So if we get X equal to 0, or you get X minus 1 equal to 0, when does this become 0? When X is equal to 1. So you can make the choice of X to be 1, because you know that if you bring it here, this will be 0, this will be 0, and that will be 0. So you remain with only this piece. Okay. So okay. So what you are doing here is this. After you multiply by this common denominator here, you multiply by the common denominator throughout here. These denominators here will be cancelling some of the parts that you have in your common denominator. And then you remain with these, multiplying each. Now I want to find the values of A, the value of B, the value of C, and the value of D. How do we do that? If we make the choice of X to be 0, since we have X here, if we equate this to 0 and bring 0 where there's X, this whole thing will be 0. This whole thing will be 0 because of this X. This whole thing will be 0. Because of this X, this whole thing will be 0. But when you place 0 here, you place 0 here, this won't be 0. We'll get -1 multiplied by 1 by B is equal to, place 0 here, you remain with 7. So we have -B is equal to 7, meaning that B is equal to -7, because you divide by -1, you divide by -1. So B is equal to -7. You keep it there. You go back. If we let X to be -1, what will happen? We'll have -1 plus 1 here, -1 plus 1, which is 0. We'll have -1 plus 1 here, which is 0. We'll have -1 plus 1 here, which is 0. But this side, we won't have a 0. It will be -1 minus 1. Now that this is becoming 0, this is 0, this is 0, then you can find the value of D. Okay? So you can find the value of D. So now we're going to have 3 by -1 plus 7 is equal to D by -1 squared, -1 minus 1. This will give us -3 plus 7, we get 4. Is equal to -1 squared, we get 1. -1 minus 1, we get -2. So we have -2D. Divide by -2, divide by -2, we have D is equal to -2. So we have found the value of B, we have found the value of D. What else? We go back and let X So we go back and let x to be equal to 1 now. Because we know that when x is 1, there will be 1 minus 1 here, which is 0. There will be 1 minus 1 here, which is 0. There will be 1 minus 1 here, which is 0. And this one won't be 0. So on the left, we have 3 by 1 plus 7 is equal to c 1 squared 1 plus 1. Giving us 10 is equal to 1 squared is 1, 1 plus 1 is 2, so we get 2c. Divide by 2, we get c is equal to 5. So we have the value of c, the value of d, the value of b. We are remaining with the value of a. Now there's nothing that we can do there for us to find a. But look, the good part is that 3 of them have been found. So if we chose a neutral number and substitute throughout, and then substitute back the values of a, b, c, and the values of a, the values of b, c, and d, then we can find a. So what have I said? If we let your own choice, any number that won't affect this equation here. Let's say x is equal to 2. And substitute, we have 3, 2 plus 7 is equal to a 2 minus 1, 2 plus 1, plus b 2 minus 1, 2 plus 1, plus c 2 squared, 2 plus 1, plus d 2 squared, 2 minus 1. What are we getting? We are getting 6 plus 7 is equal to a by 2 by 1 by 3, plus b by 1 by 3, plus c by 4 by 3, plus d by 4 by 1. 6 plus 7, 13. 2 times 3, 6a. Plus 3 times 1, 3b. Plus 4 times 3, 12c. Plus 4 times 1, 4d. But we know what b is. So we substitute. So we have 13 is equal to 6a plus 3. What is b? B is -7. Plus 12. What is c? C is 5. Plus 4. What is d? D is -2.
Sir,
Hello.
so what if I just get, maybe I get the values, the one that are on B, then I substitute the numbers that are found. Then I start like solving the others, not the way you put at once.
I can't get your question. I can't understand.
Sir, I mean like the way you've done. You've done them. You've done everything at once. You substitute like substituting everything at once. Now I was saying, what if I just like get one by one? Then
Or
I can
you do like 3, you multiply by b, you keep it somewhere, and then you come and
Yes.
substitute. It's okay. As long as you only use them to get a when you have taken everything back.
Ila saa nshimwene bwino apopwekesheni popa nono.
Look, since we have found C, we have found D, we have found B. Then there's no n number that you can pick that can make this to have some variables disappear. So we'll pick a neutral number 2. N choice. And substitute that number where there is x. And then have this equation here with letters A, B, C, D. But because I know what B is, I know what C is, I know what D is, I now substitute those known values. Then we have 13 is equal to 6a minus 21 plus 60, 12 by 5 minus 8, 4 by 2. So this means that we have 13 is equal to 6a. What is negative 21 plus 60 minus 8? We get 31. So if we take now 31 the other side, we have 13 minus 31 is equal to 6a, implying that we get 18. So we have 6a is equal to negative 18. Divide by 6, divide by 6. So we get a to be negative 3. So it means that we have found yes, each number that you choose will only enable us to get one unknown variable at a time. Now that we have all of them, we can safely say no, when you get to this point, you are free to choose a number. It won't do anything to the equation. To just give you the missing variable. To avoid expanding throughout, you may just end up making a mistake. So now we are saying, therefore, the partial fraction for this guy is equal to A is negative 3 over x, B is negative 7 over x squared, C is 5 over x minus 1, D is negative 2 over x plus 1. So the signs in between have been affected by the values that you have found, not by the sign of the numerator on the right. So this is done only when you have a repeating linear.
Sorry. Excuse me, sir.
Okay.
So here where you said let x equal to 2, you mean you can get any number for as long as it's not deleting the variables?
Yes. You can use 10,
All right, thank you.
5, or any number. Okay, so we have done 2 examples based on when you have linear factors. So log out, log back immediately, and then we finalize partial
So-
fractions.
Sorry, sir. What's the value for A again?
-3. So you can try this out. It should give you the fraction that we have on top, on the left. It always come out. So if we have x squared, x minus 1, x plus 1, then x in x squared, we get -3x multiplied by x minus 1, x plus 1. And minus 7, x minus 1, x plus 1. Plus 5, x squared, x plus 1. Minus 2, x squared, x minus 1. So if you simplify this, you must be able to get this when you're proving if it's correct. Okay, so let's log out and quickly log back.